Welcome to Star Chat, the podcast where we explore the wonders of the universe and bring you the latest news from space. I'm your host, Carl, and I'm excited to share some fascinating stories with you today. We're starting off with a thrilling discovery that's got astronomers buzzing. NASA's Hubble Space Telescope has helped uncover a hidden galaxy that's almost invisible to our telescopes. This mysterious object, called Candidate Dark Galaxy 2 or CDG2, is located about 300 million light-years away in the Perseus Galaxy Cluster. What's remarkable about CDG2 is that it's dominated by dark matter, a type of matter that doesn't emit or reflect any light. In fact, estimates suggest that a whopping 99% of CDG2's mass is made up of dark matter. This makes it one of the most dark matter-dominated galaxies ever found. So, how did scientists discover this elusive galaxy? It all started with 4 globular clusters, which are dense balls of stars that were found to be clustered together in an unusual way. Normally, these clusters would drift apart over time, but in this case, they seem to be held together by a strong gravitational force. By analyzing images from Hubble and other telescopes, researchers were able to detect a faint glow surrounding the cluster group. This glow matched the position and shape of the clusters, suggesting that it was indeed a galaxy. The discovery of CDG2 has significant implications for our understanding of the universe. It suggests that there may be many more galaxies out there that are too faint to detect, which could mean that our current estimates of the number of galaxies in the universe are way off. We'll also be talking about NASA's Artemis II mission, which has hit a snag due to fueling issues. And we'll explore some other fascinating space stories, including a pre-dawn blood moon that's set to sweep across North America. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue to explore the vast expanse of the universe, we find ourselves pondering one of the most intriguing mysteries of our time: the nature of black holes. Specifically, a team of researchers has proposed a fascinating idea. What if the supermassive black hole at the center of our galaxy, Sagittarius A, is not a black hole at all, but rather a massive clump of dark matter? This concept, put forth by Valentina Crespi and her colleagues at the National University of La Plata in Argentina, suggests that fermionic dark matter, made up of extremely light particles, could form a dense and massive core that mimics the behavior of a supermassive black hole. From afar, this clump would appear almost identical to a black hole, with the same gravitational pull and orbital patterns. However, if we were to venture closer, we might find that it's possible to pass through the center without being affected by the intense gravity of a traditional black hole. The researchers' model, based on observations of star orbits and gas clouds near Sagittarius AJ, as well as measurements of the galaxy's rotation, seems to match up with existing data. The image of Sagittarius A released by the Event Horizon Telescope in 2022, showing a glowing ring of superheated matter around the black hole, could also be explained by the gravitational pull of a dark matter core. However, not everyone is convinced. Gaston Giribet at New York University believes that the idea, while intriguing, is less likely than the traditional black hole scenario. Shep de Alaman at Harvard University also raises concerns about the model's ability to explain observations near the event horizon, where the magnetic fields seem to be consistent with a black hole. The debate highlights the ongoing mystery surrounding dark matter and its role in the universe. If Sagittarius A is indeed composed of fermionic dark matter, it would challenge our current understanding of cosmology and the standard model of particle physics. The implications are profound, and the possibility of a dark matter core at the center of our galaxy is an exciting area of research that warrants further exploration. As we delve deeper into the unknown, we're reminded that the universe is full of secrets waiting to be uncovered. The truth about Sagittarius A's may remain elusive for decades to come, but the journey of discovery is what makes the pursuit of knowledge so thrilling. Welcome back to Star Chat. Today, we've been exploring the wonders of the universe, from distant galaxies to the latest breakthroughs in space technology. But as we close out this episode, I want to share with you a fascinating story that combines science, innovation, and a dash of curiosity. Imagine a world where materials can emit light without being electronically excited, a phenomenon known as phosphorescence. Researchers have been studying this effect, particularly in the context of organic chromophores, which are essentially molecules that absorb and emit light. Recently, a team of scientists made an intriguing discovery. By dispersing these chromophores within a polymer matrix, they could induce dynamic phosphorescence through thermal stimulation. In simpler terms, when the chromophores are embedded in this special material, they can be triggered to glow by applying heat. This breakthrough has significant implications for various fields, including optoelectronics, biomedicine, and even space exploration. Just think of the potential applications: glowing materials for emergency signage in space missions, or advanced biomedical imaging techniques that don't require external light sources. The researchers achieved this feat by carefully designing the polymer matrix to interact with the chromophores in a specific way, allowing them to harness the thermal energy and convert it into light. It's a remarkable example of how scientists can manipulate materials at the molecular level to create novel properties and behaviors. As we gaze up at the stars, we're reminded that the universe is full of mysteries waiting to be unraveled. The study of phosphorescence and advanced materials is just one aspect of the broader quest for knowledge that drives human innovation. So, let's keep exploring, experimenting, and pushing the boundaries of what's possible. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.